Welcome to Fred
and Amy's Math Shack.
To start today, we're just going to recap drawing straight line graphs. So I want you to try each question and then pause the video, see if you're correct. So first one, y is equal to 5. Well, often people sort of put a point there and they think, yep, that's it. But actually, if we look at some other coordinates, like this one is 5, 5, 8, 5, they all have the same thing in common. Y is equal to 5. And in fact, the line is this horizontal one. It goes through the y-axis. Y is equal to x. Next one. Well, we can always try and plot some points if we're not sure. So 0, 0 is going to be 1. 1, 1 is going to be 1. 2, 2. And it's actually going to be this diagonal line that's going like so. You can also use the form y equals mx plus c. And I'm going to write that down because that comes in later on. Y equals mx plus c. In this case, so c is the intercept where it crosses the y-axis. M is the gradient. I'm assuming you've seen these things before. And then c is going to be 0. The gradient is going to be 1. I go along 1, up 1, along 1, up 1. We'll see that in a bit more detail in a minute. X equals minus 2. Very similar to the y equals 5 one, but this time it's going to be a vertical line. So it will go through minus 2 and look like this. Y equals minus x. Now when I've got x equals 1, I'm going to get minus 1. And what we get is this diagonal line going that way. So you can also see this as having an intercept of 0 and a gradient of minus 1. Go along 1, down 1, along 1, down 1. These are some absolutely crucial types of graphs. The y equals some constant, x equals a constant, and y equals x and y equals minus x. And make sure that you learn these, just like you can get some straight away. Okay, stepping it up, y equals x plus 4. This is when we really need to bring in the idea of y equals mx plus c. C is 4, so it's going to go through here, and then if I go along 1, I go up 1, along 1, up 1, and those 3 points are enough to give me an idea of the line. And it's going to go like so. That's y equals x plus 4. 2x minus 1, I'm starting to step it up now. It's going to go through minus 1 because that's the intercept. And this time it's going to go along 1, up 2. Along 1, up 2. That's what gradient of 2 means. Rise over run is 2. Might do a few more in this case because then I can sort of see the line even more easily and make it really accurate. Okay, because I don't want to miss any points. I want to try and get it to be as best I can. There we go. Y equals 2x minus 1. Let's keep going along this pattern. Y equals 3x plus 2. That's going to mean it there. And then this time I'm going to go along 1, up 3. Along 1, up 3. And that's a good place to start drawing my line. And then just make sure I'm now going along 1, down 3, along 1, down 3 to make sure it all fits perfectly. But you can use a ruler and you shouldn't have the problem that I do. Right, next one. Got another negative gradient. So when you get a positive gradient, it's always going up diagonally like this. A negative gradient is going to mean it's like this. It's going to go through 2. And this time, because it's minus 2, I go along 1, down 2, along 1, down 2, and so on. I can do a few more if it helps. There we go. Perfect. Right, just revisiting this. Y equals minus 1. Got to make sure you don't get them mixed up. It's going through the y-axis, going through at minus 1. There we go. X equals 4. Similar. Goes through the x-axis at 4. Okay, last two. Most challenging ones I've put in. Y plus x equals 5. Two ways to do this question. First way, rearrange. Y equals 5 minus x. Or minus x plus 5. Intercept of 5. Gradient of minus 1, go along 1, down 1, along 1, down 1, and so on. I can draw my line. Second way, I do also want to talk about this because it is a powerful method. Imagine just creating a little table, x and y, and finding out what the value of y is when x is 0, and what the value of x is when y is 0. So if x is 0, kind of imagine covering this up, and you're just going to get that y is equal to 5. Similar, when y is 0, cover it up, we're going to get that x equals 5. This will give us these 2 points here, and actually that's enough to draw the line. Going to use that method straight away in this final question, and we'll see why it's so useful. Okay, again, but this time when x is 0, I'm going to sort of cover it up. I've got 3y equals 6. I'm going to get that y is equal to 2. I'm going to plot that straight on there. There we go. And then when y is 0, cover it up. 2x equals 6. X is going to equal 3. And there we go. Those are my 2 points, and that is enough to be able to connect the line. I can actually see I'm going along 3 down 2, along 3 down 2. Like, you got a ruler, so you should be able to sort that out. That's going to be what it ends up. Whoops. Yeah, there we go. Okay, the other way you could do this question is you could again rearrange it to 3y equals 6 minus 2x, then divide by 3. So you're going to get y equals minus 2/3 x plus 2. And you can see the gradient is minus 2/3. That's how it works. But actually this is a really efficient way as well. Hopefully you're happy with that. We're going to be using these ideas today. Nothing more complicated, really. But make sure that you know your y equals and your x equals, you know your y equals x, your y equals minus x, and ideally these other y equals mx plus c ones, and these ones that are not quite in the form y equals mx plus c. Here goes, graphing inequalities introduction. So I'm going to talk about some of these. I advise you to give it a go yourself first if you can, or at least think about it before I talk about each question. I'm going to do 6 examples here. So we're not just setting y equal to a value here or x equal to a value. We are actually having an inequality. Now we need to remember how to read this. Y is less than or equal to 2. Well, our starting point here is to just draw the line y equals 2. But I don't have just y equal to 2, do I? I've got everything that's less than it as well. So this becomes a region. And here's my first region. I'm going to label it R. Next one, y is less than 2. How is that going to differ? Well, it's almost exactly the same, but what we do is we actually use a dotted line at y equals 2. This shows that it can't actually equal 2, but it can equal things up to it once I finish my inequality. I'll then finish it off in the same way, and I'll label the region R. Now, how do we remember this? It's a bit like when you learn about number lines. So if you have x is greater than 2 on a number line, then you use an open circle. If you have x is greater or equal to 2, then you use the closed circle. I've got more ink in the symbol here, so I've got more ink in my dots. I've got less ink in the symbol here, so I've got less ink in the dots. Same thing going on here. I've got more ink in the symbol here, so I've got more ink in the line. I've got less ink in the symbol here, so I've got less ink in the line. This is just a memory technique. Like, ideally, you can just remember for less than or equal to, you'll include the line, all of the line is solid. If it's less than or greater than, it will be a dotted line. Next one, got another dotted line. It's greater than minus 3. So let's get the dotted line at minus 3, and then it's going to be everything above. It does say to label it R, so we better keep doing that. Okay, I'm going to shade it as well, just to make it really clear. X is less than 4. Have a go at this one. Once you got the hang of the first 3, hopefully you can give a good go to the next 3. So we're going to have a dotted line again, and it's going to be at 3. I haven't quite put it in the right place. Here goes everything to the left. Y greater or equal to x. This time I've got an including x, so it's going to be a solid line. And we know from previous that I'm going to get this line going diagonally like so. Let me try that again, because actually the scale misses out 6 here. So I'm going to do it 5, 5 to minus 5, minus 5. That's clear enough. Right, let's just think about this carefully. I'm interested where y is greater than x. I can see, look, it's going to be bigger up here. So the region is going to be above the graph. Generally, if it's y is greater than, it's going to be above the graph. If it's less than, it's going to be below the graph. There are some special instances we need to be careful about. And then this last one, y is less than 5, dotted line at 5. It's horizontal. And then at minus 3, we put one here. And this time it's minus 3 is less than or equal to y, which is less than 5. I've actually got the region in between. Isn't this great? For these inequalities, we can find these shaded regions. Okay, here are a few more for you to try. And here are the answers to these. So this time I've shaded them in green. I haven't actually labeled them with R. I should have done that, but do you know what? I'll do it now. I should label them all. All right, let's keep going. Second lot of examples. So this is when I get two inequalities on one graph, and I need the region to satisfy both. So we need to be a bit careful. Okay, first of all, we've got y is greater than minus 1. It's going to be a dotted line at minus 1. There we go. And I'll worry about the inequality aspect in a minute. I'm just going to get the line down now because that's important. Then the second one, let's do y equals 2x plus 1. It's going to go through 1, and then it's a gradient of 2, so a long 1 up 2, a long 1 up 2. Got my line. It includes the point, so it's going to be a solid line. There's quite a lot going on here. There we go. All right, let's think about the region now. Don't rush the region. So it's everything greater than minus 1, which means it's everything above here. So I'm just going to draw some little arrows to show that it's got to be above. And then it's y is less than or equal to 2x plus 1. So it's everything below this line. And that will give me my region. It's going to be this thing here. Okay, if you're confident, try this next one yourselves. I think I'm going to deal with the bottom one first. It's just a little bit easier to draw. There we go. Okay, I don't want to include minus x. Sorry, I just did that wrong. Well done if you spotted that I've just done y equals x, but it should have been minus x. Okay, there we go. I'll worry about what else is going on in a minute. And 3x minus 2. Put one at minus 2, then I go along 1 up 3, along 1 up 3. Again, it doesn't include it. That's good enough. All right, then this time it's y is greater than minus x. It's everything above it. and then y is greater than greater than 3x minus 2. So everything above that as well. And I've got my region. Here we go. Hope that makes sense when I'm shading this bit. Yeah, it's not here. It's got to be above this line and it's got to be above this line. Right, try these ones here. And here's the answer. So I've got 2 lines going on here. I end up with 3 lines going on here. You need to be a bit careful because x is not clearly labeled on my graph. I probably should have done that. I'm going to do it now. X greater or equal to 0 is actually going to be this vertical line here, and then everything to the right of it. So I've not put the arrows on all of it, but I hope you can understand that. It wouldn't actually carry on here. It would just stop at the x equals 0. All right, and that is the main content from today. Hopefully you're happy. I just want you to practice a few more questions, and this will bring in a few extra aspects. So try each one, and then I'll go through them. So first one, let's take it steady. So I've got the x is greater than 1. So let's get that line in. Y is, greater or equal to 1. Y is greater or equal to x. So let me get that one in. And then finally, x plus y is less than or equal to 7. 2 methods for doing this. Rewrite it as y equals 7 minus x, or use that other coordinate method I used. It's going to look like this. Let me just quickly go through that again. So it's going to be y less than or equal to 7 minus x, and then I've just used the intercept and the gradient. The other method that I've spoken about previously is to draw a little grid. Do x is 0, y is 0. I'm going to get 7 and 7 if I make x equal to 0 here and y equal to 0 here. When I'm finding out when it equals 7, okay, that's the temporary bit to get the line. Right, now we need the region. I mean, to be honest, it's often going to be the region that's enclosed, but we shouldn't assume that. We should always just check. Everything to the right of x equals 1. Everything above y equals x. And then everything below 7 minus x. And you can see that gives us that region in the middle. This time I'm just going to put an R here and point to it. Maybe I shouldn't do that. Let's not do that. Let's just write R here and shade around it. Now, just one point to make. What if it was quite difficult to rearrange y, or I didn't know how to do that? Well, you can check a point. I could maybe check a point here and see that, right, 4 plus 6, is that less than or equal to 7? No. So I know it's not going to be in the region. It's not going to be above the line. It's got to be below the line. That's another way of figuring it out. Whereas if I did 2 plus 4 for this point here, then 2 plus 4 is less than or equal to 7, and I'm done. The only other thing I'd say is that sometimes you get asked questions like, write the coordinates of the integer points within the region. So then I'd be labeling like all of these. The coordinates, I should say the coordinates with integers. There's quite a lot in this case. You wouldn't be asked it here, but I still illustrate the idea. Okay, one more to try. Just going to show you the answer to this one. Here's one we did earlier. Okay, not going to go through all the steps, very similar to before. Right, extension time. Have a go at these questions. There's a lot going on here, but it's the same kind of idea. Can you label each region? Here are the answers. Okay, if I'm talking about this quickly, I would probably make y the subject here, right? Y is less than or equal to 3x minus 5. Get that line drawn. It's a solid line. Got y is between minus 5 and 4. So it's going to be this region. I've not like done all the arrows here, but I'm hoping you're happy with this. You get this region here, and similar for this second one. And finally, just thought I'd throw in one that's not just a linear graph. Okay, on graph paper, can you shade the region that satisfies these inequalities? Give this a go. Okay, hopefully gave that a go. This really is an A-level question, to be honest. I don't think on GCSE you will be asked about quadratics, but it doesn't mean we can't do it because it's the same idea still. So here goes. I need to bring this to the front. This is what it ends up looking like. So you could actually factorize this expression, although it wants you to plot it. So really you'll need to make a table of values to be able to plot this. And you'll need to be able to do it for the y one. I'm not going to go in any more detail on that, but well done if you did manage to solve that one. Okay, and that is our lesson on graphing inequalities, introduction. Next time we're going to look at what if I gave you the region, like so, and ask you to write down the inequalities that it's described by. That sounds like good fun, but for now, we'll leave it there. Hopefully you're happy. You can draw these lines, you can shade the regions, you can do it when there's multiple lines. You can do it maybe even when there's a quadratic in there. Good, good, good.